All right, so we are going to list all of the factors of 12, which would be 1 and 12, 2 and 6, and 3 and 4. And we will divide that by all of the factors of 10. That would be 1 and 10, 2 and 5. So everything on top, if I take that and divide it by 1, I would just get everything that's on the top. Then I have to take everything on top and divide it by 2. So 1 divided by 2, that's 1/2. 2 divided by 2, that's 1, and we already have that one. 3 divided by 2, 4 divided by 2 is 2, and we already have that listed. 6 divided by 2 is 3, we already have that. And 12 divided by 2 is 6, we already have that. So now we'll go through and take all the top and divide it by 5. So 1 divided by 5, 2 divided by 5, 3 divided by 5, 4 divided by 5, 6 divided by 5, and 12 divided by 5. Then we have to take everything on top and divide it by 10. So you have 1 divided by 10, 2 divided by 10, but 2 divided by 10 is 1/5, and we already have that, right? 3 divided by 10, 4 divided by 10, but that would be 2/5, and we have that already. 6 divided by 10, that would be 3/5, and we already have that. And then 12 divided by 10 would be 6/5, and we already have that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 32 possible rational roots. And at most, 4 of those are going to work, right? Now remember, your roots, your zeros, those can all be rational. You might have 2 rational and 2 irrational. You might have 2 rational and 2 imaginary. I mean, the possibilities just seem endless. So to help us, in figuring out which one of these might possibly work, I'm going to graph this equation. So I have 3 of these in here. I'm graphing this third one. This is the one we're on right now. All right, so when we graph that, it should look like this. Now, if you will notice, see how this crosses the x-axis 4 times, right? That means I have 4 real zeros. Remember, if we get imaginary zeros, that means that if it crossed twice, I would have 2 real, but the other 2 would be imaginary if it didn't cross again, all right? But if you notice, none of these cross at an integer, right? They don't cross even anywhere. So when you're looking at your answer choices, it's not any of these, right? So these are your only options. So here's where you're going to kind of use your table to figure this out. So if you look at, let's say this one right here, I would say that looks like it could be a half or maybe a little bit more than a half, but definitely not a whole, right? It wouldn't be above 1. So when you think about fractions, remember, like this is more than 1 because 2 will go into 3 one whole time, correct? So this is 1.5. So it wouldn't be this one. I don't have anything there. So I'm going to try 1/2, but then also what's something that's just a little bit more than a half? Maybe like 3/5, right? Okay. So I'm going to try 1/2 and see if that works. So I'm going to activate my table by pressing second table, and I'm just going to plug in 1/2. Now, when I plug in 1/2, I'm looking for a 0. Did I get a 0? No, so it's not that. So I'm going to try 3/5 and see if 3/5 gives me a 0. So when I plugged in 3/5, I got a 0. So I know that that's one that I'm going to want to divide by. So 3/5 should be one of my answers. So I'm going to divide by 3/5. All right, so I've got nothing missing. So I've got a 10, negative 11, negative 42, 7, and 12. And I'm going to go down through here. So I'm going to drop the 10. 3/5 times 10 is 6, plus a negative 11 gives me negative 5. Negative 5 times 3/5 would give me negative 3. Negative 42 and negative 3 give me negative 45. Negative 45 times 3/5 would be a negative 27. Negative 27 plus 7 is negative 20. And negative 20 times 3/5 would be negative 12, which gives me my remainder of 0. Now, I've dropped down to 10x to the third, right, minus 5x squared, minus 45x, minus 20. And I could try to factor by grouping, but I will tell you that it's not going to work, okay? Sometimes it does, sometimes it doesn't. In this case, it doesn't. If you wanted to try it, you know, on a problem and see if it works, then you could. Or you could try to find another spot where it crosses. So to me, this looks like it's crossing at like negative 1/2 right here. So I'm going to plug in negative 1/2 in my table here. See if that's correct. All right, so when I plug in negative 1/2, I get 0. So I know that I can divide by negative 1/2. So I'm literally just going to take what I had left over from going through the division once, and I'm just going to drop that down. And I'm going to go through the whole process again. So I drop down the 10. Negative 1/2 times 10 is negative 5. Plus a negative 5 is negative 10. Times negative 1/2 is positive 5. Plus a negative 45 is negative 40. Negative 40 times negative 1/2 is positive 20, which gives me a remainder of 0. So the first time that I go through the division, I drop down from an x to the fourth to x to the third, right? When I divide again, that drops me to x to the second. So this would be 10x to the second minus 10x minus 40 equals 0. Now I have a quadratic, right, that I could try to factor. And if you notice, all of these terms can divide by 10. So I'm going to go ahead and divide both sides by 10, which is going to give me x squared minus x minus 4 equals 0. And when I see a trinomial like this, I always want to try to factor. So like, is there anything that will multiply to make 4 and subtract to make 1? I mean, 4 times 1 is 4, but that subtracts to make 3, right? 2 times 2 is 4, but that subtracts to make 0. We don't have any other options. So I can't factor this to solve it. And when you can't factor a trinomial or a quadratic, then you have to use what in order to find your solutions? So we'll use the quadratic formula because I can't factor it. So my a value is 1, my b is negative 1, and my c is negative 4. So I've got x is equal to the opposite of b, so that would be positive 1, plus or minus the square root of b squared. And remember, it's really important to put that parenthesis around your b. Minus 4 times my a, that's 1, times my c, that's negative 4, all over 2 times a. So the first number you always want to find is the number that's underneath the root. Don't put the root in, okay? Just put the stuff underneath the root. If you do that, you get a 17. And then 2 times 1 is 2. Then if you can reduce that root, then you should. 17 is a prime number, so therefore I can't reduce that, correct? And this is actually 2 answers, okay? I have 1 plus the square root of 17 over 2, but then I also have 1 minus the square root of 17 over 2. And then my other 2 answers were negative 1/2 and, was it positive 3/5? Is that right? Notice that's 4 answers, correct? So all of these answers are real. How many of them are rational answers? How many of these 4 are rational answers? 2. Yes, these 2 are rational, correct? How many of them are irrational? 2, because I've got those roots in there, right? But all of them are real because I don't have any i's, correct? Now, if I had gotten an I, I would immediately know that's not correct because I crossed the x-axis 4 times, meaning I have 4 real zeros, okay? All right. So at number 9, we're going to take all the factors of 4, which would be 1 and 4 and 2 and 2, right? So 1, 2, and 4. And we will divide that by all the factors of 6, which is 1 and 6 and 2 and 3, right? So 1, 2, 3, and 6. So if I take everything on top and I divide that by 1, then I would just get everything on the top. Then I need to take everything on top and divide it by 2. So 1 divided by 2 is 1/2. 2 divided by 2, that's 1. We already have that. And 4 divided by 2 is 2. We already have that. So now everything divided by 3. 1 divided by 3. 2 divided by 3. And 4 divided by 3. Then we have everything on top divided by 6. So 1 divided by 6. 2 divided by 6, that's the same thing as 1/3. We already have that. And 4 divided by 6, that's 2/3. We already have that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 16 possible rational roots. All right, so we're going to grab our calculator and we are going to graph that just so we don't have to keep guessing, right? All right. So the middle one's what we're graphing. All right, so again, none of the numbers that are integers are going to work, right? So none of these are going to work. It's going to have to be one of your fractions, right? So let's go ahead and look. This looks like a half to me, right? And if you look over here, I've already plugged in a half. When you plug in 1/2, you get 0. So I know I'm going to divide by 1/2, all right? Then it only looks like I have 2 other options here, right? And actually, this looks like it curves right here. And I'm going to zoom in on this so you can see. See how it comes a little bit below there? So it looks like it's turning on the x-axis, but it actually isn't. And earlier, I thought it did, and we almost did the problem wrong. So you got to be careful because sometimes it does weird things, right? All right. So anywho, I know that 1/2 will work, and then we have 3 other options, right? We have a couple that are right here, and we have one right here. This one is in between 2 and 3, right? So that means that your bottom number of your fraction would have to be able to go into the top number. 2 times and a little bit more, right? Do you have any options like that? 3 does not go into 1, 3 does not go into 2, 3 goes into 4 one time, right? 6 doesn't go into 1. You don't have any options that are bigger than 2, so this is going to have to be something different, right? So over here, this looks like it might be like 2/3. Do we have a 2/3 option? A negative 2/3? So for the table, let's try negative 2/3. And when I plug in negative 2/3, I get 0. So I know I'm going to be using the negative 2/3 and a positive 1/2. So we'll do the 1/2 first. I've got 6, negative 11, negative 16, 2, and 4. So drop the 6. Half of 6 is 3, plus a negative 11 is negative 8. Half of negative 8 is negative 4, plus a negative 16 is negative 20. Half of negative 20 is negative 10, plus 2 is negative 8, and half of negative 8 is negative 4, so I get my remainder of 0. Then we have already decided, right, that we're going to use the negative 2/3 and divide again. So drop your 6, your negative 8, the negative 20, and the negative 8. Drop the 6. Negative 2/3 times 6 is negative 4. Negative 8 and negative 4 make negative 12. Negative 12 times negative 2/3 gives me a positive 8. Negative 20 plus 8 is negative 12. Negative 12 times negative 2/3 is positive 8, and that gives me my remainder of 0. So the first time you divide through, this would be an x to the 3rd. The second time you divide through, that would be x to the 2nd. All right? Now, all of these will divide by what? 6. So I'm going to go ahead and divide them by 6. The next term would be 2x minus 2 equals 0. If you wanted to go ahead and write these down here like this and then divide by the 6, that's fine. And you may want to make yourself a note out to the side that we went ahead and reduced by 6. That way you wouldn't be going, where on earth did we get the 2, you know? So I would try to factor this. I always try to factor if I can. So is there anything that multiplies to make this 2 and subtracts to make 2? No. So we're going to have to use the quadratic formula. So our a value is 1. Our b value is negative 2. And c is negative 2. So that would give me x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times 1. So find the number under the root first. If you plug that in, you get 12. Now, 12 is not a prime number, so I need to think about splitting 12. So you can do one of two things. You can do your factor tree like we did before. You know, 2 times 6, and 6 is 2 times 3. So that gives you 2 to the 2nd times 3, and then you square root, right? So you end up with 2 square roots of 3. Or if you want, you can say, okay, I need to split 12 into a perfect square and a prime number, and the square root of 4 is 2, right? So I'm going to go ahead and replace the square root of 12 with 2 square roots of 3. And then I realize that both terms on the top will divide by this 2 on the bottom, so I'll reduce. 2 divided by 2 is 1. 2 divided by 2 is 1. And now I'm reduced. So 2 answers here. You have 1 plus the square root of 3. You have 1 minus the square root of 3. You have negative 2/3, and you also have 1/2. So we have 2 irrational answers, 2 rational answers, 4 answers in total, and they are all real. All right. Also, I will point this out as well. Let's say that you're not real confident about these. You're not sure that you did your whole, reducing and simplifying correctly. You can go to your calculator and plug that answer into the table. So if I go to the table and I do 1 plus the square root of 3, it might give you this weird thing, but remember, this is like scientific notation kind of stuff. It gives you 12 zeros in front of this, which is 0, right? And if one of them works, then the other one also works, so you don't have to worry about checking both of them. Okay. So number 10, we're going to list all the factors of 12. That would be 1 and 12, 2 and 6, 3 and 4, right? So 1 and 12, 2 and 6, 3 and 4. And we will divide that by all the factors of 3, which are just 1 and 3. So we'll take every number on top and divide that by 1, which would just give me every number on top. And then we're going to take every number on top and divide it by 3. So 1 divided by 3, 2 divided by 3, 3 divided by 3, but that's just 1, 4 divided by 3, 6 divided by 3, that's 2, and 12 divided by 3, that's 4. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 18 possible rational roots. And we're going to graph this so that we can, cheat the system. That's what we'll call it. All right, so it looks like we have 4 real roots because we're crossing 4 times. And it looks like we cross evenly right here on 1. So I'm going to go to my table and just check and make sure that I get a 0 when I plug in 1. And I do, right? But we're going to need another one. So this is 1, 2, 3. This one would be something that's bigger than 3. So if you check out your possible answers here, do you have a fraction that would end up being more than 3? No. Okay? So this is probably going to be one of the ones that I get when I, end up in the end with something I need to either do the quadratic formula for or just solve for x. So this one doesn't look like quite a half. It maybe looks like it might be a negative 1/3. So I'm going to check and see if negative 1/3. And it is. So I'm going to use 1 and negative 1/3. Let's start with the 1 just because why not? So we have a 3, negative 2, negative 37, 24, and 12. So I'll drop the 3. 3 times 1 is 3, plus a negative 2 is 1. Times 1 is 1, plus a negative 37 is negative 36. Times 1 is negative 36, plus 24 is a negative 12, times 1 is negative 12, and I get my remainder of 0. Then I'm going to do that same thing again, but I'm going to use the negative 1/3. So 3, 1, negative 36, and negative 12. Drop the 3. Negative 1/3 times 3 is negative 1, plus 1 is 0, times a negative 1/3 is 0, plus negative 36 is negative 36, times negative 1/3 is 12, and I get the remainder of 0. So remember, when you divide the first time, it knocks it down 1 degree. So now you're down to an x to the third, which means this will knock it down to x to the second. So this is 3x to the second. And then you don't have an x, right? So you don't write that one. And then you have your minus 36 equals 0. Now, I don't have to do the quadratic formula on this one because I can just solve for this x right here. So I'm going to add the 36. That gives me 3x squared is equal to 36. I will divide by 3. So x squared is equal to 12 square root. And don't forget that when you square root, you're going to have a positive answer and a negative answer. And we reduced 12 in the last problem. It ended up being 2 square roots of 3, right? So that gives me 2 answers. I have positive 2 square root of 3. I have negative 2 square roots of 3. 1 and negative 1/3. And I did not put those in order. So I have 2 rational, I have 2 irrational, I have 4 total zeros, and they are all for real. Now, before we talk about the next thing, I want you to make a connection with something. So on all the last 3, we've had a root in our answer, right? We have this root was in our answer. This was in our answer, these 2 roots. And then you have these 2 roots. What do you notice every single time we have a root in our answer? What do you notice about them? There's always a positive and always a negative in front of this root, right? If I have a 1 plus the square root of 17 over 2, then I also have a 1 minus the square root of 17 over 2, right? If I have 1 plus the square root of 3, I also have a 1 minus the square root of 3. If I have a positive 2 square root of 3, then I have a negative 2 square root of 3. I always have a positive and a negative root. So that's going to feed into our irrational conjugates theorem, which says if I have a polynomial function that has rational coefficients, and a and b are rational numbers, and the square root of b is irrational, if a plus the square root of b is one of my zeros, then a minus the square root of b is also one of my zeros. So when they give you the zeros in here, notice they're only listing 2 plus the square root of 5. But because of this theorem, I know that if 2 plus the square root of 5 is a 0, so is 2 minus the square root of 5. So they want me to write a polynomial function f of least degree, meaning the smallest degree I can get, that has rational coefficients, meaning I don't want any roots in my answer here, a leading coefficient of 1, so a 1 in the front, and has these zeros, okay? Sometimes they'll give you both of these, so you don't need to write them twice, okay? But if they only give you one, then you need to include the other. So what they're doing is they're giving you the answers, and you have to work backwards to find out what the original equation was. Normally we get the equation, right? And then we work through and find the answers. So before I get to the zeros, I always set those equal to 0, right? So this factor would have been x minus 3. I have to actually change the sign of that 0 right there. And then I have to do the same thing to both terms in this one. So this would be x minus 2 minus the square root of 5. And this would be x minus 2 plus the square root of 5. Now, normally we would take the first 2 parentheses and we would multiply those, right? But I'm not going to do that this time, and I think I mentioned this the other day. If you have a root and a root, you want to do those together first, because what's going to happen is after I multiply these 2 together, because they are conjugates, they're going to cancel out all the roots, and that's the part I want gone. So I'm going to leave the x minus 3 alone, and I'm going to go through and multiply these 2 together. So x times x gives me x squared. x times negative 2 is negative 2x. X times the square root of 5 is x square roots of 5. You just smash them together. All right, then we've got the negative 2. So negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. And negative 2 times the square root of 5 is a negative 2 square roots of 5. Then we've got negative square root of 5 times x is negative x square root of 5. Negative square root of 5 times a negative 2 is a positive 2 square root of 5. And a negative square root of 5 times a positive square root of 5 is negative 5. If you will recall, anytime I multiply two of the same roots together, they just end up being the number under the root. All right? So I'm going to keep the x minus 3 up here, and I'm going to go ahead and combine my like terms. Now notice, I have a positive x square root of 5, and I have a negative x square root of 5. That cancels. I have a negative 2 square root of 5 and a positive 2 square root of 5. That cancels. Now I don't have any more roots, right? That's the goal, okay? If you have roots left, then you've done something wrong, all right? And it was probably something to do with your signs. So I've got the x squared. Nothing will go with that. I always end up with 2 of whatever this is. So see, I have a negative 2x and another negative 2x. That makes negative 4x. And then I put together the 4 and the negative 5, which makes negative 1. Now I've eliminated all the roots, and I'm just going to multiply again. So x times x squared is x cubed. X times negative 4x is negative 4x squared. X times negative 1 is negative x. And then we're going to go do the negative 3. Negative 3 times x is negative 3x squared. Negative 3 times negative 4x, positive 12x. And negative 3 times negative 1 is positive 3. Now, up here they said write a function f, so we'll call this f of x is equal to, I only have one of the x cubes. Negative 4x squared and negative 3x squared make negative 7x squared. And negative 1x and positive 12x make positive 11x. And then I have the plus 3. See, I have all rational coefficients, a 1 in the front, and I had 1, 2, 3 zeros, and that's the degree. All right, number 12, exactly the same. They've told me that I have a 0 of 3, and I have a 1 minus the square root of 5, but I know that if I have a root, that there's another one, right? So the other one would be 1 plus the square root of 5. So I'm going to write my factors here. So this is a positive 3, so this will be x minus 3. So conversely, if this was negative 3, then you would have x plus 3 here. Then I've got x minus 1 plus the square root of 5. And then I have x minus 1 minus the square root of 5. And we are going to start with the back 2. So x times x gives me x squared. X times negative 1 is negative x. X times negative square root of 5 is negative x square roots of 5. Then take and distribute your negative 1 times x is negative x. Negative 1 times negative 1, positive 1. And negative 1 times a negative square root of 5 is a positive square root of 5. Now distribute your square root of 5 times x is x square roots of 5. Square root of 5 times negative 1 is negative square root of 5. And a positive square root of 5 times a negative square root of 5 would be a negative 5. So I'll keep the x minus 3 in the front. and combine my like terms. So I know that the negative x squared of 5 and the positive x squared of 5 cancel. The positive square root of 5 and the negative square root of 5 cancel. So now I'm left with x squared. Remember, I told you you're always going to have two of these, so a negative x and a negative x make negative 2x. And then the 1 and the negative 5 make negative 4. You should have no roots left, and then you're just going to multiply again. So x times x squared is x cubed. X times negative 2x is negative 2x to the second. And x times negative 4 is negative 4x. Now the negative 3 times x is negative 3x squared. Negative 3 times negative 2x is positive 6x. And negative 3 times negative 4 is positive 12. Said write a polynomial function f, so this is f of x, is equal to, I only have the 1x cubed there. Negative 2x squared and negative 3x squared make negative 5x squared. Negative 4x and positive 6x make positive 2x. And then you have the plus 12 at the back. All right. So same thing on number 13. We have a 2. And then we have a 3 plus the square root of 7, which means we also have 3 minus the square root of 7. Since this is positive 2, this would be x minus 2. And then I'm going to have to change the sign of both of these, so this would be x minus 3 minus the square root of 7. And then x minus 3 plus the square root of 7. And then we're going to multiply those back two together. So x times x is x squared. X times negative 3 is negative 3x. And x times the square root of 7 is x times the square root of 7. Then distribute your negative 3. So negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And negative 3 times the square root of 7 is negative 3 square roots of 7. Then distribute your negative square root of 7 times x is negative x square roots of 7. Negative square root of 7 times negative 3 would be a positive 3 square root of 7. And a negative square root of 7 times a positive square root of 7 is a negative 7. So I'm going to leave the x minus 2 in the front and combine my like terms. I have a positive x squared to 7, which will cancel with the negative x squared to 7. A negative 3 squared to 7 that cancels with the positive 3 squared to 7. And then I'm going to combine the rest of my terms. So I have my x squared. Remember, you always have two of these. Negative 3x and negative 3x make negative 6x. And then you have a positive 9 and a negative 7, which makes 2. Then we multiply again. X times x squared is x to the third. X times negative 6x is negative 6x to the second. And x times 2 is 2x. Then distribute your negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 6x is positive 12x. And negative 2 times positive 2 is negative 4. And then I'm making a function f. So I have the x cubed. Negative 6x squared and negative 2x squared make negative 8x squared. 2x and 12x make 14x. And then you have your minus 4.